Hey AP Stats, hope you're all safe at home for your e-learning day. So as we kick off some of these, you're going to need access to more advanced graphing calculator software than what you probably already have. Since most of you don't have the TI Inspire that we use in class, I suggest going to desmos.com, and it gives you this. A lot of you have probably worked with this already. So Desmos.com, they also have an app. I want to show you the normal CDF function, which is actually pretty new for Desmos. But let's see here. We start by, I'm going to give you a problem, and I have it basically all worked out until the normal CDF stuff. So to familiarize yourself with the problem, according to the Association of American Medical Colleges, only 46% of medical school applicants were admitted to a medical school in the fall of 2006. Upon hearing this, the trustees of Striving College expressed concern that only 77 out of the 180 students in the class of 2006, that's a year, not a class size, who applied to the medical schools were admitted. The college president assured the trustees that this was just kind of the year-to-year fluctuation in fortunes that is expected, and in fact, the school's success rate was consistent with the national average. Who is right? Well, A, what are the hypotheses? I said null hypothesis that 46% get in. And then the alternate is that 46% don't get in. If you claimed that another alternate hypothesis could have been that less than 46, I think that's fine too. That just affects our p-value later. Check the conditions. We're assuming these students are independent and representative of the type of people that are that are applying. And 180 of that sample is less than 10% of all med school applicants. 10 successes, 10 fails, both met. So we proceed with the one proportion z-test. So I built the model, 46% in the center, that's our null hypothesis. I already went ahead and found your standard deviation right here, 0.0371, and I found a p-hat from the sample. So now I can take it, I want to find a p-value, which means I need my normal CDF. Going back to Desmos. So here you're going to want to click, I'm going to attach the keyboard super quick. So clicking up here, and it should bring up some options. Right here, this is where it is. Click up to show the keypad, go to functions, and surprise, we don't go to stats, we go to distributions. Normal distribution is going to give us normal dist, and you just kind of see that you have the little normal distribution bump there. In the problem, it gave us 46% as our center. Oh, it's out there. 46 is our center, and our standard deviation was 0.0371, I think. Oh, yep, 0.0371. So now if I scroll a little bit, it gives us this looking weird window. Don't worry about that because we actually don't need to see it, but I'll show you how to adjust it in a second. What we really want is the CDF function right here. So click it, and it'll give us the options. We want to find negative infinity, the low tail, negative infinity down here, all the way up to our p-hat, 0.4278. So 0.4278. So we see it auto shade, super cool. But we have a p-value of about 19%. So if you were giving this hypothesis test not equal to, you double that 19% to about 38%. So you'd definitely be failing to reject either way. There isn't sufficient evidence that the proportion of acceptance